Brian, can you hear me?
Good morning.
Great. All right. So let's get started. And so welcome to SCONE, Standard Communication of Network Element Working Group session. And it's a great pleasure to meet you guys in Thailand, Asia at this time. My name is Qing Wu, and I will co-chair with Brian Chamel, who is available online. And okay, let's move on. And note where apply, probably you have already read this note where, and this is all about the IETF process and RPI rules. And please bear in mind all what you said will be recorded and deemed as a contribution to the IETF. And note really well, although we come from different group, different organization with different background, but we have a common goal is to make the internet work better by producing open standards and protocols. Please respect each other, focus on technical discussion, and even though we may have some disagreement, debate on some technical issue. For people attending in person, and please make sure sign into the session using Media Echo on-sign tools because we will use these Media Echo tools to record your participation. And we will use Media Echo to, so you can use Media Echo to join the microphone queue. And if you are not presenting anything, please mute yourself and keep your video off. And this rule also applies to the remote participants. And if you are not presenting anything or you not sharing the working group session, please mute both video and audio off. And for remote participants, the headset is highly recommended. So administrative, and so as a working group chair, we will use Media Echo to manage the queue. And if you make a presentation, you want to make comments, please stand up or come to the microphone, identify yourself before you make a comments. And we also have a chat and Jabber, which has already integrated into the Media Echo. So you can keep track of the chat window. And if you have any thoughts and idea, and please share on the chat window if you don't have chance to make comments before the microphone. And we don't have a physical blue sheet. Media Echo has already automatically track your participation. So please do sign into the Media Echo using your data track account. And for note taking, actually we have Martin Duke. Yeah, thank you for volunteer. And we also appreciate if anyone else who also can log into this notes.ietf.org and to help identify some missing discussion points. So here's the working group status since last IETF 121 doubling, and we has already agreed to set up a 2 work stream. One is focused on semantic contents, the other focus on protocol framing. And after doubling, actually, we successfully scheduled 2 interim meetings and to drive the progress of these 2 work streams before this meeting. And the outcome of this 2 interim meeting is we made a progress on the merger protocol proposal. And we, as working group chair, has created a working group GitHub for the converged protocol proposal. So we actually see both trend protocol proponents and SCONE quick protocol proponents to work together. So you probably see the new merging there. Their version individual has been posted called Tron. So this will be the basis for today's discussion. We're also looking for the established experimentation and pre-interoperable before the material meeting. And during one of the interim meeting, we do review one of the experimentation proposal from Meta, and we get discussed on the list. But we still, haven't reached a lot of agreement on how this work can be proceed. So we encourage, all the problems to think about how to proceed this work, what is the way forward, and continue to drive this. And here's the goal for today's discussion. I think the focus of today's meeting is framing and syntax work stream. really want to reach consensus on the merger protocol proposal. Hopefully this serves the basis for the working group document. In addition, we received 2 new proposals, which are more related to the semantic contents workstream and also applicability, manageability China item. And the first proposal is about SCONE taxonomy and try to explore impact of sorting policy. The second is to explore how to implement the SCONE in the mobile network environment. So after that, we will, to discuss, how to plan for more intermeeting until the next major meeting. So here's the agenda for today's discussion. We will spend 1 hour for this work item, frame and syntax workstream, and I think Marcus and Martin can lead this discussion. And in addition, we will spend 20 minutes for 2 new proposals. The first proposal is about the SCONE mobile network use cases. This has already been introduced in one of our interim meetings, and by the way, see author actually document these cases, and we will discuss this again. And the second proposal about SCONE taxonomy sorting policies, and hopefully these 2 proposals will be good input to applicability China item. And we for each proposal we'll assign with 10 minutes, and we also reserve 5 minutes Q&A and if needed. And then we will plan the next step, and after these 2 presentations, and any agenda bash? If now, actually, I have 1 more slide. Actually, we know actually a lot of problems actually post a new draft. You want to progress your new idea. Actually, we suggest really if you want to make more progress for your worker, we strong encourage make good use of the mailing list to socialize your proposal, your idea, and look for comments, and try to resolve all the open issues on the mailing list. And in addition to progress your own work, please also consider to review other people's work. For example, review the change to the working group document during the adoption stage, working group last stage, IETF last call stage. So this is most important to progress the existing working document, since this will leave more room for the new idea, new work item. If you have some topics that has common interesting and actually set a high priority, you can request the virtual meeting resource from the chair. We're happy to get it set up, and we already plan the interim meeting after this Bangkok. And if you have some topic require more attention, need a better scope, you also can request the informal working meeting from the chair. And please make sure you also send this informal meeting announcement on the list to make sure engage more people, get more people eye on this proposal if you really want to make more progress. With that, let's kick off our discussion. And the first is about protocol merge protocol proposal. Marcus or Martin, who will lead this? Yeah. Yeah.
Hello. All right. I am Marcus. We're going to talk about drone questions and perhaps some solutions. So this is a discussion of kind of a merger of two kind of vastly different protocols. And as you might have seen, there was something published already, but then during this week, we all met up, and what we present now looks a little bit different from what was published prior to the meeting. So we will try to go through some of these open questions and see if we have some answers to them. So.
Can you make it work?
You need to like click the slice clicker thing there, and then plus, yeah, there, and
this one?
Yeah.
Okay. Yes.
Okay. All right. So we have a bunch of issues. We're going to jump straight into them. one of the contentious topics that we have discussed through a couple of interims and so on is how we want to encode the throughput advice. So we have the train proposal, which defines the use of 6 lower bits in the first octet of the Tron packet, where you have kind of a table. You're mapping a bit towards an entry in a table, so you have a one-to-one mapping between the bit and the throughput. One of the criticisms we had of that is it can be quite difficult to select pre-select values and fill a table with that. It's kind of hard work to do to make it future-proof. So that was one. And then kind of on the other end of the spectrum, we had SCONE, which had a self-describing 32-bit value. So pretty much you could express a bit rate in kilobits per second, encode it in 32 bits, and send it on the wire. That's probably way more granularity than we need. You can express a huge range of bit rates with a very fine-grained, very fine granularity. And it also, on top of that, it requires more parsing by a network element, because now you don't have the bit field at a fixed offset. You have to first parse the lengths of connection IDs and so on. So that's also a bit problematic. And then what was published prior to the IETF was just like, yeah, let's make this value TBD. So that's not perfectly useful either. So what we did among these authors was that we got together a few days ago and started discussing, like, can we find a way to make this, can we reconcile these things about wanting to have quite high granularity, but not too high? And how do we reconcile the issue of like selecting the right values to map these bits to actual rates? Yeah, so what we proposed, and we will spend some time explaining this, and please come with clarification questions if you have them. We have a lot of time here. So what we proposed is something we call a version-dependent bitrate field, leveraging the low 6 bits of the first octet, so kind of the train model, to express a range. But instead of using a kind of pre-selected table of values, we decided we want to encode the bit rates in a logarithmically spaced distribution over a range starting from some lower value to some upper value. So the rationale for this is that we kind of care about having quite a lot of granularity if you want to express low bit rates. So if you're interested in expressing a rate limit of, say, 100 kilobits per second or 200 kilobits per second, you kind of want to have some granularity there. But if you want to express a rate limit of, say, 20 megabits per second, you probably don't need granularity enough to say that the nuance of having 20.01 megabits per second, right? So we think, how can we most efficiently make use of these 6 bits? So if you decide to encode the bit rates with a logarithmically spaced distribution, it's kind of a geometric series if you want, you then get a nice property of having fine granularity at the lower range. So if you see the example here, we chose an example exponent here that is kind of nice to visualize. So we start at the lower end of the range where n equals 0. So when all the bits are 0, you have the value 0, and then that maps to the lowest bit rate. Here we call it bmin, and in the example we represent 100 kilobits per second. And then each step you multiply the minimum bit rate with this exponent, and then you get this nice series starting at 100 kilobits per second at 0, 112 at 1, etc., etc. You get to slot number 20, and you have now 1,000 kilobits per second, and you see that it increases nicely, in this case up to, what do we have there, like 100 or 12 megabits per second. And then finally we have the value 63 to express that there is no limit within this range. And we have some clarification question already. We will have multiple slides explaining this further, so yeah.
Anton Franco, Huawei. Bmin and Bmax are negotiable or stable in your scheme?
So what we are proposing is that these will be stable. So, and we will come to this as well in further slides. So in the specification, we decide on basically Bmin, maybe Bmax, or we decide on Bmin and an exponent, and Bmax will follow from that. So this is something we would have to agree on, and this is also why we call it version dependent, and I will come to that we actually propose to have two versions with two different values of this Bmin, so you can express different ranges.
Okay.
But it's not something you negotiate in a protocol, no. So why do we do this logarithmic thing? Well, as I already say, it's an efficient way to encode a large range of bit rates. Like if we use a 32-bit value field, we have a very high granularity throughout the entire range, which is something we probably don't need. With a logarithmically spaced distribution, we can use few bits to encode a very large range. And we get then most granularity along the lower bit rates, and the higher the rate we want to express, the more coarse graining we can accept. So if you look at this, what we show here is it just shows the absolute difference between one bit rate and the bit rate prior to it in the list. So you see it's an exponentially increasing difference between one bit rate and another in this particular series that we're using. So it just shows how it gets more and more coarse grained as we move up in the bit rates. And we have Abhishek, more clarification?
Yeah. How do you encode the unit? So Bmin is 100, but how do you know it's kbps?
It's the specification says so.
Okay,
So if you know the protocol, you have to know how to interpret this, right? So and that will come down to the semantics track as well, right? Exactly. I mean, what do we want to express here? Here, this is a range of values. This is we have 6 bits, 64 values in total. We set them, and then the protocol says what they mean, right? So we determine like the exponents, we determine the starting point, and we determine that this is kilobits per second. But that's for us as a working group to discuss and agree. Like just to, like the previous question, like these are values that are fixed. It's not something negotiated. So if you're using this protocol, this is what it means. Yeah. So we said version dependent. And what do we mean with that? Well, the proposal here is that we define 2 Tron versions, which means that we use 2 different quick versions. So if you remember how train and Tron works, I kind of skipped a lot of the background here. Maybe I should have put in a bit of background on how these protocols work. But how it works is that you basically, what you do is you send a Tron packet that is glued onto an end-to-end quick packet. So they share a UDP datagram, and in front of the end-to-end quick packet, you have a Tron packet that is sent with a quick long header. And the Tron packets have a specific version. So this is how you detect in the network that a packet is a specific Tron version, right? And what we propose here is that we define 2 Tron versions, which then maps to 2 different quick versions, and different versions maps then to different ranges where they have different starting points. So for instance, we can have version A, where the lowest bitrate is 100 kilobits per second. So you get the max value of 125 megabits per second in this range. You have a version B, where the lowest value of the range there is 10,000 kilobits per second, which means that that range can express values up to 12.5 gigabits per second. And then it would then be possible for senders to kind of alternate sending of packets with either version, and the network elements would update the rate fields in these versions, and the receiver of these Tron packets would select the minimum value out of those Tron packets of those both versions to be the one that you should probably adhere to. And we can then, aside from just choosing different starting points, we can then look into having nice bike shedding discussions on how to define these exponents, because if we choose slightly different exponents for these different versions, we also get, we have the possibility to kind of overlap the regions of bit rates that these versions express, right? And if we have slightly different exponents, we have the possibility to get quite fine granularity in this range that overlaps between these ranges. And I see we have some more people in the queue, so please come up with clarification questions.
Abhishek, are you in the room? Okay, next, Antonio.
This reminds me of a discussion about negotiation for codecs in multimedia communication. And while we are at defining different versions for encoding the bitrate, why don't you design a method so that if in a given specific use case, I'm interested in a very narrow range of bit rates with not a logarithmic evolution, but linear or whatever, or even a matching table, then I can place this encoding in the protocol so the people that agree on using this encoding for the bit rate can use it on the wire. So in fact, instead of setting in stone something in which you use a logarithmic evolution with two different starting points and trying to look at overlapping regions for having a better granularity, you specify a mandatory to implement way of looking at the bit rate, and then you leave room for people with a specific need in given use cases to have a better definition of the bit rate evolution or mapping they want.
Right. I think there are a lot of things you can do around this, but it all boils down to like simplicity versus like how expressive do we want this to be? How much kind of negotiation do we want involved? Because if you look at the intended use case for this, it will be kind of a lot of endpoints in sort of unknown networks will be sending these probes in order to understand if there is something on this network path that might want to express some rate limit. And I might not have that much knowledge. As an application, I might be aware that I'm more interested in certain ranges over others. But then we also come to the question, like, if I send some very specific range, that will also tell the network something more about me as an application that I might want to express. So there are a lot of trade-offs here. And I understand that we can definitely fine-tune this stuff. But yeah,
that's why having this as a mandatory to understand method is very good, because then if you don't have any negotiation, you do this, and this gives you a means of communicating your bit rate.
Yeah.
But what I'm saying is beyond that, you can specify methods. So people with specific need can design their own mapping and bitrate understanding method.
Sure. So, I mean, if you're on a very known path with a very known problem, you could define your own rate. Yeah, that would be something to consider. I think that should probably not be the primary focus of this group, but that, of course, will be up to the working group to work on. Yeah. Martin.
Martin Duke, Google. Just a quick question. So if I send version A and version B, if it's like a lowish, if it's only in the version A range, then I'll get the actual numerical response to version A. Version B will return a 63, right?
So if you send both versions and the actual rate is in the lower range,
Yes.
so on version B, you will get the value, you will get the lowest value, you will get value 0, which is probably higher than the rate that is expressed in version A.
Okay.
But you will have a lower value in version A, and you as a receiver will select the minimum of these two, right?
Okay. So if it's in version, if it's in the version B range, then version A will return 63.
Version A will return 63.
So 63 means larger than the range,
60,
not
yeah, exactly.
outside the range.
Exactly. 63 means that the bit rate, there is no limit in the range that I can express in this range. That's what it means. So it might mean that there's no limit at all, or that it's a larger limit. It just says in this range there is no limit. Yeah.
All right. I'm not sure you're phrasing that in a way that makes sense to me, but okay, I understand what you mean now. And so if for some reason I'm on a horrible link with terrible bandwidth, I'm going to get a 0 on both of these.
That's possible. And then you know that the rate is
Below
something
100.
lower than what version A can express, right?
Understood. Thanks.
Or it could be the lowest value of version A or lower, put it like that, yeah. Yeah, this just, I don't know how well this shows. This just, okay, we have two ranges here. Here we show like the distribution of bit rates over these ranges. We have version A in the top, we have version B in the bottom. It looks the same, but if you look at the y-axis, you see that it's vastly different. Of course, we don't see much here because the range is very high. But what's interesting is if we show these two instead of showing them in a linear scale, we show them in a logarithmic scale. So we see that the blue line here is the bit rates expressed by version A. The red line here is the bit rates expressed by version B. And depending on how we select the starting points, we then get these regions of overlap that we can that might or might not be useful, right? And then we can discuss like how we want this overlap to be and so on. But we're able to express very large differences in the bit rates, but we also allow for a certain overlap between these two ranges. And I see we have more people in the queue, I think. Abhishek, yeah.
Yeah, Abhishek. Two questions.
Yep.
So one is, so let's assume that the bitrate has been communicated properly. Where will the so there are two entities involved, the network element and the endpoint. Where will it be specified how to interpret that? How to measure that bitrate? Over what windowing period? Over what averaging window? And
Okay, yeah.
where will that be mentioned?
It's a later issue that we will discuss, but yes. So the proposal, I mean, I can do a preview here. The proposal is that we describe guidance in the draft on what these rate limits mean and guidance on how they are measured over what time intervals and how you should interpret them both as a network element and as an endpoint. But we can discuss that. It will come. We have a full separate issue on that topic, so maybe we can punt that question until then. Yeah.
Okay. Second question. So the two bmins for the two different versions,
Yep.
will they be hard specified
Yes.
in the protocol? So then, I mean, then you can avoid the overlap. Why do you think?
The thing is, there is value with overlap, right? Because and this is something we can discuss as a working group. We can completely avoid overlap if we want and expand the range even further. But with some overlap, there is also there's value in the overlap because again, how you select which range to express as an endpoint, that can kind of fingerprint a little bit what you're interested in. But if you have a range overlap, you can just keep alternating these things. You have the ability to extend the range, but you also have the overlap. So it doesn't really say that much about you as an application. Also, there are some ideas that we will need to discuss further on. I won't spend time here, but if you carefully slightly select different exponents or starting points of these ranges, you have the possibility to have very fine-grained fine granularity of rate limits in this overlapping region, right? And then if we carefully select these overlapping regions to be in a range that is quite often used by networks, at least today, then there could be some value in that. But I mean, this is stuff for us to discuss as a working group. This is one proposal to have some overlapping ranges here. It doesn't have to be, but it's one potential here. And I see we have one more person in the queue after.
Luis.
Hi, this is Luis. Something that is not clear to me, probably I missed something. You mentioned that always the lowest value will be selected. So will be always selected the blue one, right?
Okay, so the lowest of the two, but the blue, so if the actual value the network wants to express is somewhere on the red line here, above the overlapping region, what you do in the version that expresses the blue is that you set the value 63. That means that the actual rate limit is something higher than what's available in this range.
Okay, thank you.
Any more questions and clarifications on this? I'm happy to take that because, yeah, it's a little bit dense.
Marty.
Yeah.
How often do you expect us to go back and define a new version to get a new range?
The idea is that we wouldn't have to do that very often because that's why we wanted to start off with two ranges and use a logarithmically spaced distribution, because it allows us now to express ranges from 100 kilobits per second up to, in this example, up to 12.5 gigabits per second, right? So we're hoping that we won't come back in 5 years and have to say that, this new XR use case that I want to rate limit, we don't have good rates to express that. Now we have that. I mean, maybe 5 years from now we realize that we need more granularity in some range, and maybe we express a new version. But it's really, the intention is really to come up with a good large range from the start here. Yeah, that's the hope. You know, then what happens, we'll have to see. Okay, are we? So this is our proposal for the rate limit field. So maybe to summarize, our proposal is to use the low 6 bits of the first octet in the Tron packet to express bit rates. We propose to use 2 versions with logarithmically spaced distributions, which allows us to have a very large range of bit rates. And yeah, this is the proposal. Yeah. Martin. Yeah.
So one thing that Marcus hasn't really pointed out is that we expect that the version A will cover essentially most of the video use cases with a bit of slop on either side. So I can't imagine many people delivering video are doing so at 100 kilobits per second today. That's not a great experience typically. And once you get to the, I think it's what, 120 megabits per second, that's probably a little higher than a lot of people would be interested in delivering for standard, typical scenarios. Obviously, uncompressed video at 8K is probably a little bit above that, but most people consuming video would be doing so compressed, and so you would probably fit mostly in the middle of that range. Yeah. And that's the idea of that range there. The version B that Marcus is talking about is really in anticipation of future needs and cases where, I don't know, you're doing short form 8K video or something like that, and you want to get 500 videos down to someone's phone so that they can go flip through all of those videos in less than a second. That sort of thing is a little bit unreasonable when we think about it today, but there are a number of use cases like Marcus was talking about. If you're looking to deliver XR video, the bit rates are potentially a little higher than the range that we sort of have for the version A. And being able to say that we have the opportunity to just add another version with another range of values for some unanticipated use cases is relatively easy to do. Yeah. So we decided just to stick one on the top. I think Matt had a use case that was in the sort of hundreds of megabits per second range, which is an interesting one, and that doesn't fit within the first range very well, but it does fit in the second one. On the lower end, I think.
Yeah.
Hi, Alvestra. Just noting that in audio calling, we routinely have to deal with congestion on bit rates that go below 100. Yeah. And in AVT Core the other day, there was presented a web video codec that for uncompressed high definition video that would use 2.5 gigabits. So all ranges are interesting.
Right. Yeah, that's a really good point. And even so that all ranges are interesting, and I think that's good. We have to keep in mind what we're trying to express here is potential rate limits that a network can expose as well, right? So it's not, yeah, it's good to have a huge range. We probably won't need super fine granularity, but yeah, like you say, that even at the lowest ranges, there are codecs that pass through. Yeah. Mia.
Mia Kuhlewind Eriksson, just to 2 points, just to reply to Harald quickly. So I think the low ranges are not interesting. These are the congestion ranges, but that's usually not where you put your rate limit. To handle congestion, you have congestion control. So I don't think we have to have them here. The other point is on extensibility. I mean, we're trying to cover a very broad range, but like I think history has shown that it's really hard to make guesses about future traffic. So I think we will never be on the safe side. We need extensibility. The extensibility model here is using a new version, which is harder to deploy than any other extensibility model. So that's the question we should need to discuss. Is that the right extensibility model regarding deployment?
Yeah, I don't know if it's much harder. I mean, a new version is.
Yeah, maybe I'm very pessimistic here, and it would be really sad. But I think like the version number can ossify easier than other things. But that's a matter of opinions, I guess.
Yeah.
Dan Drutter. I just want to make sure that everybody understands that we're talking about bit rates here, more of an aggregate session bit rate rather than the bit rate that the encoders and players are talking about. I have a draft video session data rate that sort of try to explain that when we're talking about the 4 tuple, it's really the aggregate of all the video streams that are there. So just to avoid confusion when we talk bit rates in this context, is really aggregate bit rates for the.
Yeah, I absolutely agree. And I think we did spend some time in the chartering of this working group to talk about terminology, and I think we probably need to spend a bit of time for when we're, before we publish something here to talk about the right terminology. And I think you have a good point, especially some of the use cases that Martin mentioned and Matt and so on, where you have, you're frequently flipping across videos. So it's not just one video, you're prefetching content for multiple videos and so on. So it's not just one simple video stream that we're talking about usually. So that's right. Yeah.
Next.
Christian Wittemer. Yeah, I mean, I love this design. I mean, I regret I could not be in Bangkok and be in the room with you guys, but it's a great job. And one thing we should not lose sight of is that that's not the only way to control bit rates. I mean, the Mirya was mentioning congestion control. The network has a known way to do congestion, to indicate fine-grained congestion control with things like ECN. So basically, we can use this range to do a broad selection. Say, like, if my range is at most 2 megabits, I'm not going to try to switch on a 10 megabit codec. But I will definitely listen to the ECN marks and say, oh no, actually, they said 2 megabits, but right now there is something happening and I can only send 0.5. And I will have to do that too. This is not RSVP, that's just an indication.
Absolutely, I 100% agree. This rate limit is a coarse-grained ceiling, like an absolute ceiling for your traffic, and then you have other congestion events that determine your actual rate, and this works perfectly fine together with L4S and ECN and so on. And I'm not sure if we need some guidance in the document as well, just to make sure that I mean, I think the charter is already clear about this, but yeah, we probably need to cover this in whatever we publish as well.
A quick clarification from Haran for note taking. Did you mention, Harald, did you mention the example that you gave in AVT core? Was it a compressed video, 2.5 gigabits per second, or uncompressed? What did you say? Okay.
Uncompressed was the answer there. Okay. Who's up next? I don't know if the queue is.
Renjie Tang, are you online?
Yeah, this is Renji from YouTube. Just a clarification question. So for this current design, are we only limited to like sending just one piece of information, just the bit rate? Like, what if in the future we want to communicate more information? Do we have to make a new version?
Yeah, exactly. So what we're saying here is that what we can express with a Tron version is what's specified here, and what we specify is the first 6 bits that gives you a rate. If we down the line realize that this is completely insufficient for whatever use cases we have, it's possible to mint a new version to go through the standard process and agree that we need to express something different. But we have to keep in mind that the document that describes these bit rates, we do need to have sufficient guidance of what these rate limits mean, how to interpret them, what kind of averaging windows we're talking about, and so on. But yeah, the current proposed design is that we express what's dynamically expressed by this protocol is the rate limit and not other parameters. Yeah.
Yeah, just to add to that, in putting together things, the original SCONE proposal had effectively a 2-dimensional expression, which was effectively the bit rate and the time over which that bit rate was expected to be enforced. And the problem with that is that it's difficult as a network element to know whether your choice is strictly lower than the one that's coming past you. So having a one-dimensional signal allows us to do that much more effectively. If you imagine that you have a bit rate that's set to 5 megabits per second over a 1 second window, and you get something coming in that says, oh, 2 megabits per second over a 3 second window, is yours lower or higher than the one that's coming in? And do you replace the one that's there with yours, or do you let it past? And that's a difficult question in that case, whereas a one-dimensional thing is much more straightforward. You say, well, my limit is lower than the limit that's coming past, I'll apply that, otherwise leave it alone.
And exactly, and also we can decide on some guidance and some fixed, more or less fixed averaging window and so on. Then different networks might have different ways of enforcing it still. But of course, if you, as a network element, detect non-compliance to a rate you want to enforce, you have a few things at your disposal, right? One is that you can reintroduce throttling. The endpoints can detect that and they can adjust their sending behavior, or you have the possibility to send a lower rate limit in subsequent Tron packets. That's also a way to kind of indicate that the way you're doing as an endpoint is not really complying with the policy I have at this point in the network. So and that's why it's nice that we have a pretty good range here, and all along the common values we have a pretty much granularity. So if you detect non-compliance, you can communicate that in various ways.
Next, Gori.
Mia Kulevin, I just reply to Martin. I disagree. I think one rate is lower than the other. That's very clear. If you give the timing window, that's just additional information which actually allows the endpoint to go a little bit over the rate from time to time. But like the thing you compare on is the rate, and it's very clear which one is lower. So I think this is not a difficult. You can make it difficult, but we can also just make it easy and decide that way. I don't think that's a problem.
Gori?
Yeah, Gori Fairhurst, just as an individual, trying to get some clarity on limit and ceiling and words like this. As I saw it, this was throughput advice. This was simply saying, if you stick to this, then I have a contract to do that. It doesn't actually constrain the sender. Is that my understanding?
Yeah,
correct?
It doesn't constrain the sender. This is advice. This is an advisory signal saying that over this network, it is likely that if you exceed this, something might happen. But that's it. It's not congestion control. It's not forcing you to do anything. It's purely advisory. Yeah.
Sure. And the element in the middle that does this is at liberty to change that whenever it feels like.
Exactly. Yes.
Without necessarily enforcing it at all.
Exactly. Yes.
Yeah. Good. Thanks.
Martin Duke, Google. I think I agree with Miria. I don't think it's that hard to figure out this algorithm. I think if you have the lowest rate, you update the rate, and if you have the lowest update time, the lowest earliest expiration time, you update the expiration time, like as a separate algorithms, and then so that way the user or the endpoint knows the lowest rate limitation and also knows when it needs to send another SCONE packet. But maybe you have slides that explain a different way of ensuring timely updates. So I'll defer my final opinion until I see that. Thanks.
Oh, okay, Marcus, you mentioned like, okay, you send a throughput advice, and then you're also like kind of monitoring. And then if the application is not complying by, you can also send another one like, hey, you are not doing it. You just said that. My understanding is current Tron design is like network is not generating any kind of packets by itself, so it's actually so basically the network has to wait on
exactly, and we'll come to that point.
Okay, good.
Guidance on how to send and so on. Okay, but yeah, I mean you have two options as network element. Either you when you can, and we'll discuss when you can send this, you have the possibility to send something new, or you can start throttling, and by throttling you will most likely drop packets, and that in itself is a signal to the sender as well. Martin, you're still in? Okay. Yeah. Okay. So yeah, this was our proposal on the ranges. we got through this far. Any more questions before we jump to the next topic? Okay, great. This one will probably be a little bit faster, but you never know. So Zahed's question was timely because we're going to talk about this specific issue right here. When can throughput advice be generated? So we have had 3 ideas floating around. In train, advice are generated when an endpoint sends a train packet, and it's up to the endpoints to do that as they see fit. SCONE was kind of a very different model where it is expected that the network element generates its own SCONE packets at the time where the network element sees fit. Tron as published was largely based on train, but put in some guidance text on when a network element potentially can expand a datagram that contains an end-to-end quick packet and kind of squeeze in a Tron packet. That has a bunch of complications as well. Like if you try to expand a datagram in the network, you might mess up the path MTU. So we put in some guidance that you should only do this if the payload of the UDP datagram is not going to be larger than 1200 bytes, because that's what you reliably expect that quick endpoints can support and so on. But yeah, there was some text around that. But proposed way forward here is that, and this is largely dependent on if we agree on having this 6-bit field, which is easy and cheap to update, it is quite okay to have a relatively high frequency of sending Tron packets from the endpoints. So we expect that we can put in some guidance to the endpoints who want to exchange bitrate information, that you could, for instance, send a Tron packet once per video burst. If you're like an HLS or Dash sender, you can put some guidance in there. If you detect persistent congestion like ECN marks and packet loss, that might be an indication from the network that that there are lower rates at play potentially. Or if there's an address tuple change, there's a migration event happening, the path may change. So that's a good time to also generate advice. So we propose to put this kind of guidance in. There is, of course, a choice if we want to make the protocol have explicit defense against networks trying to expand datagrams. I don't think we need to put in explicit defense against that. So it would be theoretically possible for a very eager network element to kind of insert a Tron packet if it can. But if we have the right kind of guidance and it's cheap enough to update these rates, it's probably not going to be needed. So
yeah, so the point here is that a network element adds one of these packets to one of to the quick packets that it's sending in order to provide an opportunity for the network to attach a signal. And so it decides how often it wants to do that. You say persistent congestion here. It's not persistent congestion in quick has a very specific meaning. It's not persistent congestion that we're talking about. I think the condition that you would be looking for is if your congestion controller tells you that the bit rate has dropped below what your throughput advice is, you would probably go and look for some more advice in that case. That's the sort of thing that we're talking about. And it's going to depend on application, I think, to a large degree, what the specific send pattern is. If you don't care what the network has to say about throughput advice, you just never send these, which may be the case for clients in these sort of video delivery applications. They just never send them. Whereas if you care, then you would send them as often as you care to receive the signal in return. But having some advice like this means that the right thing happens in those cases.
Next, Danny.
Hi, thanks. Sorry, I feel like I'm a little bit fuzzy on all of this, but I appreciate the discussion about it. It sounds to me like the discussion about when an endpoint should start to emit these, for example, if you're about to change addresses or something like that, if you're about to hand off, could potentially end up resulting in a leak for people who are trying to do a network blinded transition, right? So if I know that I've set up a new connection ID that's going to be a persistent connection migration, then I'm doing that specifically to blind the network from the fact that there's migration. If I suddenly start throwing in drone packets because I'm about to do the transition, and that's why I want to start preparing something, that seems right. So the concern about all of this is like, what extra information am I leaking by adding these pieces? And if you have a lot of explicit guidance that says do it in these contexts, then that's an additional type of information that's leaking, even if it's not a bit on the wire.
Right. I agree. We have to be careful with that aspect, and I think we're not proposing here to do it in anticipation of an address change, but rather after you have observed a change in address, you might send new Tron packets. If you're still interested in observing that, is this the path that I'm now on? Is this path also updating rate limits? Then that's an opportunity to probe this new path. Of course, if you are conscious about not wanting to send Tron packets over paths or so on, then you as an endpoint have the ability to not do that. But it's important that this is not in anticipation of a path change. It's rather after the fact that you have changed path. You might want to probe that path. That's the guidance here. But I agree, this is a topic that we need to discuss, and we have to be careful with whatever we propose. Yeah.
Right.
So yeah, +1 to I should say Brian Trammell as individual. +1 to we need to be careful about what we propose here. I'd see that there being a bunch of text in the combined protocol document about this. I think part of that is we probably want to have a little bit of maybe not guidance, but examples of what sort of signaling rate we're anticipating in these, like actually looking at how often we're sending these packets, because I think that will make it easier to have some of these discussions that we're currently having in the abstract. I did actually get in line for a clarification question. The current proposal is not to explicitly guide or deny the midpoints from injecting a Tron packet in a datagram as in previous Tron, or are we saying that this is only supposed to be sender admitted?
So there are two ways. Like, I think that what we said here is that we will not specifically tell network elements to generate Tron packets, but you have a choice here. If you really want to explicitly defend against network elements injecting their own Tron packets, you need to have more protocol mechanics. You maybe need some kind of frame on the inner connection that actually verifies that Tron was appended to this packet. But if we go down that route, that is quite a lot of work on explicit defense, and we're not advocating for that at this point.
But
again,
as an implementer,
working group to discuss, right? But
But as an implementer, I mean, like, because of the PMTU issues, I'm pretty sure that I don't want a network element to put stuff in. I can just model the PMTU and make sure I pad out to that, right? Like, so there's an interesting balance here that I think,
If you really don't want that, then you just put garbage in the end.
Got it. Okay. Cool. Thanks.
Mia Kulevin. So the challenge here is that the packets are sent by the endpoints, but the signal is actually not controlled at all by the application endpoint. I mean, yes, an application can decide it wants a signal or not, but it's a network that actually decides on what's the rate limit. As today, you have a throttler, and the throttler can just decide at any time to use a different rate. And the quicker you get this information to the endpoints, the more useful the signal will be.
Absolutely.
And that's the point. And it can only be the network that actually knows when it's decided to change the rate for whatever reason. So that's the challenge we have here.
Absolutely, I fully agree. And the kind of two ways we have here is that either you have the network explicitly deciding when these are sent, or you let these be sent frequently enough that it is timely enough. And if we do things like sending it once per video burst, that is already a very high frequency, and there will be very few applications that will find the advice useful to be more timely than that, because if you're in between video bursts, there's not really much you can do. But yeah, I mean, again, these are all trade-offs we need to discuss. We need to find a protocol that is useful, but also not overly complex, right? So,
Martin Duke again. Okay, so I'm glad Brian asked the question. So I guess we're just not saying anything about whether or not to inject stuff. I'm a little concerned that I have to think about this more, but that sounds dangerous to me. It sounds like there needs to be very carefully, network elements would need to keep a lot of state to make sure they're only adding this to connections that are like that have demonstrated interest in SCONE.
Yep.
It seems like the signatures of these short header packets could be potentially confused with other things. I mean, I could be convinced with some analysis it's okay, but I'm a little scared. And it seems to me like there would not be that much protocol to enforce this. I mean, it would expand the scope of the document a lot because you would have to like define a quick frame inside the encryption envelope to say like, I added SCONE to this or not, but it would probably deter the sort of helpfulness. Anyway, like I think we should think about that more. Thanks.
I think it's an important discussion to have. I don't think we need to solve it prior to having something that we can adopt by the working group, and yeah, be happy to keep discussing this topic. Yeah.
Jonathan Lennox, I feel like this conversation is being a little sloppy about you, as in you choose to send Trone, because there's two endpoints in this thing, and the one that, it's the server that needs to send the Trone packets, the media sender, but I think there's people saying, oh, when the client's in this situation, it should send Trone, and that doesn't make any sense. So we need to make sure that the choice either is being made by the media sender based on the information that it has, or we have some sort of quick message to say, please send a Trone packet now.
Definitely, this is an interesting topic because, yeah, for instance, in the case of video, the server generates the Trone packets, the client typically consumes them, right? And then, yeah, guidance around that is probably needed. Will we need some more protocol to be able to express, potential frequencies and so on? Maybe. Again, good work for the working group to discuss. I don't think we need that at this point to get something adopted. But I agree, it's an important topic. Yeah.
Christian.
Yeah, I mean, we had a discussion of that earlier in the train proposal on the train GitHub, and I don't know whether we carried the issue on the Trone GitHub, but the problem with injection from the network is that if you prepend a version packet in front of the other packet, and the receiver doesn't understand that version, then the whole packet is dropped.
Yep.
And so that's something that you want to do carefully.
Absolutely, and I think so the two options here. One is like either we go Martin's route here and we do full defense against that, or we maybe need to put some guidance in that you only do this if you have sufficient state to know that on this tuple there has been Trone packets going back and forth and so on. So some guidance wouldn't be needed or explicit defense.
And we can have the discussion later. I mean, basically, but basically the application is able to, I mean, the endpoint is able to sense issues from time to time. I mean, it sense whether the congestion has increased. It sense whether the bandwidth is now doesn't. I mean, there is no packet loss. There is no delay. There is no jitter. Maybe the bandwidth should be higher. So the endpoint can use signals to trigger a Trone packet, and we probably need to write that down in the next versions.
Yep.
Mia Kulevin, so you can also just put the packet at the end, right? Not a problem. No, if the network element is assigned at it, then yes. This is a short header packet. Okay. I just wanted to say that I think usually you need state anyway for SCONE because you want to potentially treat different flows with different rates, or you want to connect it to some kind of policy or whatever. So I think that's that's the usual assumption that we work on, that you need per flow state, and that you would probably only implement it in devices where you can have per flow state, or you already have per flow state today. That's not a limitation.
Jahid, I'm liking like what we're discussing here, but I just wanted to mention like, well, when we're expecting network to put the throughput thing to help the client and the server, we also need to think about like what's the network still in it. So I was thinking like more about if the network in a really bad situation, like it actually wants to send the message to the client. So I was thinking like, how does it express that? How does it tell the server, please send a Tron message, because I really, you'll be benefited by doing this. I think the condition control and other things will come in when there's a persistent condition and all stuff like that. But here I was thinking like, what I was hearing, like someone said like, hey, there should be some way of telling the server, please send a Tron packet. Instead of network generating it, network can just do that, or the client can do that because it's having some issue or changing something in its network that is connected to. So we might actually need to have more discussion, like to make a bit of like the network to have its say. We cannot just completely ignore that part, like network will only implement this thing if this is benefit in it. So then they need to say when they have issues also.
Sure. There are many ways you could do that. One way is that if something changes and you have no ability to express that, one way to express that is, for instance, if you are rate limiting, that you reintroduce your rate limiting, or you change your rate limit to a lower value, and if you throttle, then this is something that would definitely be detected. But of course, there could be more direct ways to signal this, and I think absolutely we need to discuss this. Yeah.
Sanjay Mishra, Verizon. So I'm just going to step back a little bit. If you look at the problem that we're trying to solve that exists today, is the client goes and fetches the manifest, right, and picks up whatever bit rate things that it wants from the manifest and sends a request. And as the request goes through, this, in the uplink process, the network decides that as to what's the best rate that it can support for this flow. And then regardless of what it is, what the client is asking, if what his client is asking, the device or on the UE is asking, if it matches what the network can allow, then it goes through. But if the client is asking for more than the network will allow, then you would experience a throttle, right? So that's the problem we're trying to solve, that we want to avoid that situation. And if we know already from the network what's the best optimum rate I can use, then that's the one I would request. So that's the problem we're solving here, right? That we want to know from the network what is the best rate I can use.
Yeah, absolutely.
Right?
Fully agree.
But,
yeah.
and then the second part of it is that what happens when the user device changes network? So we want to, do you want to actively solve that, or do you want to passively wait for the client to send the packet and then for the network to say that, oh, you were sitting on the 5G network for the last 30 minutes, but you didn't ask for it, so I didn't tell you that you can go higher.
So I think changing networks can mean many different things. If you have if you take your example here, like you're going from 4G to 5G, you're still, then in that case, you're still on, from the end-to-end perspective, you're still on the same network. Your IP address doesn't change. You typically wouldn't change your anchoring point. So there's no noticeable change there. Of course, do you then want the network to be able to timely send something new, in this case, because the network might know that? Then again, we're coming back to the guidance here. Is like, how frequently does the application or the endpoint make it possible for the network to send new information? If you have a design where you send this, you speculatively send Tron packets to more or less every time you burst out new video data, then that is about as high, that is about as timely as it gets. Because every time there is a new burst of data, the network has an ability to update and tell the endpoints about new rate limits that might be in effect, right?
Yeah, I actually meant the radio access technology, not changing the network. What I meant was that we have solved for the case one is clear that the endpoint send the Tron packet and network can put the advisory, which is fine. But the second case that I'm talking about is that when user ends ends up changing the radio access technology. So you move from 4G to 5G or 5G to 4G, then in that case, the question is that does the network waits for drone packet to come, then it updates the advice that, oh, you were on 4G, so I only said you can go up to 2 megabits per second. But now you're on 5G network, and maybe you can go on to up to 10 megabits per second.
No, I mean, in this model, you would wait for the next Tron packet, right? But if the Tron packets come frequently enough, that's not a big issue, right? If it takes 200 milliseconds to get your next Tron packet, or 2 seconds, I think you're fine, right?
So you have to see the balance as to what works best to flood the network with, Tron packets, or just have the network send when it thinks that it needs to send an update.
Absolutely, I agree. And again, it's a trade-off of like protocol complexity, the amount of state that we need to have in network devices, especially because we want to design this mechanism to be, any network element on the internet should be able to implement this. So we have to be very careful with how we design this. Yeah. Okay, so on a similar topic, okay, we have Gori in the queue.
Gori, not going to ask a question on. Wait, the microphone's falling apart. I'm not going to ask a question. We're going to revisit this, aren't we?
Yeah, for sure.
Because at the end, we might choose just one of these as being the way to go forward, but at least we have options now. Am I summarizing right?
I mean, of course, we're talking here about something that we can adopt as a working group, a baseline. I'm sure we will have lots of fun discussions on the nuances here. Okay, yeah. So one important topic is how do we how fast can the network know that that an endpoint might support Tron? This is an important topic, we think, because the earlier the network knows that it is likely that Tron can be supported on this for these particular endpoints, we might be able to skip doing things in the network like DPI and client hello parsing and stuff that's going on today in order to enforce some of these policies. So what was described in the different proposals that were out there was that with train, I mean, the first train packet comes after you have negotiated end-to-end. You send transport parameters end-to-end in order to negotiate train support, and then once you see the first train packet, or potentially if you are a network element that parses client hellos, you can detect that this is traffic I want to apply policy to. SCONE was more that the again, you need a full handshake end to end, and then you announce SCONE support to the network. So again, you had a problem here that the network might do some DPI parsing and so on. And Tron was the same as train. What we are proposing here is that we allow the client to attach what we call a Tron indication packet after the quick initial in the first UDP datagram as an opportunistic signal of Tron usage. Confirmation of actual usage is, of course, done by observing real Tron packets on the path. So basically, because we cannot prepend a quick initial with a Tron packet, because that would trigger version negotiation and all kinds of stuff, but we could put a Tron hint at the end of a quick initial as opposed to just padding it with garbage. And this allows a network element that would normally do like trying to decrypt the client hello or decrypt a quick initial to find a client hello and so on, to just see a quick initial, look at the end of the packet, see if there's a Tron hint there, and then it can skip the following DPI procedures that it might do otherwise.
Martin Duke, I'm sorry, I find this slide very confusing. Can you go back one? So is the proposal that like all this, like
this is stuff
DPI?
That was described before in previous versions.
Is there a previous version of Tron?
Yeah. That's what I said. We published something prior to this meeting, and then we had a session among authors, and we're proposing updates to what was published. So we should have been more clear in the slider. This is the old Tron.
Okay.
Sorry about that. Yeah.
Okay. Like The server hello, I don't even understand what the server hello thing could be, because like that's not where the transport parameters are. You can't, like, middle boxes cannot observe the server transport parameters, so you can't see if the full negotiation has happened.
Yeah, but you
maybe-
can do. So the point here is that what networks do today is that they do trial decryption of quick initials from the client. They try to find the client hello and the SNI field, and they try to, okay, I do my policy based on guessing that this is video. What we want to solve here with Trone is the ability to say that, hey, I'm a flow that is interested in potentially getting rate advice. So I can indicate that already in my initial by adding some value here. If we go back to, let me see, by adding a Trone hint, this tells the network element that this flow is interested in rate limits. We're not sure if it actually can receive them, but it's enough information to potentially not having to go in there and try to parse the SNI and all this stuff that they do today.
Okay, so because it is too late to wait until the capability.
Yes, it's too late to wait, because normally they would look at the first packet to. That's why we want an early hint here. Yeah.
I understand now. Thank you.
So I'm going to jump the queue briefly before Martin. We are currently at time. However, I do not want to stop this conversation. I think we're making really good progress, so we're going to go a bit over. I noticed, Marcus, you have 3 more slides. I do want to get to those 3 slides, and then Jin and I are going to do a couple of sense of the room questions. So let us please get to that. So keep. Matt said in the chat earlier that we put the more controversial questions early and the less controversial questions late. Let's see if he's right. But yes, let's go over a bit to continue to allow this to continue. But please keep it brief. Thank you.
Yeah, so we have covered most of the difficult ones. I'm uncertain about the value of this one, because if the client sends the Trone hint, there's no guarantee that the server's going to send Trone packets thereafter, right?
Absolutely.
And so you're in this state where the network has greater than 0 probability of getting something through, but it's not guaranteed.
Absolutely.
And the same applies if you see a new flow on that path that has been migrated onto it.
Sure.
The same thing applies. That said, I mean, this is harmless. We put zeros in that bit, so we can put any random garbage in the tail end of a packet, and it'll be fine.
Yeah, and I think to that point, like what you can do as a network is that if you see this, and if the network is okay, or if the client is okay to expose this, that means that if you don't see Trone packets, you might still apply a rate limit by throttling, right? And you already have policies today that do that based on SNI parsing, but now you have the possibility to apply your throttling even without having to resort to parse the SNI and such.
So Jahid, so for my first impression is this is like optimization kind of thing. I'm already like a bit scared, like, okay, my network need to now think about all the different quick versions that actually support Trone and all this thing. Now I'd like to get that one. So I'd like to get the value proposition here, like, and it sounded like an optimization, like what we could do. What I was thinking, like, if I see a particular quick version, that also already tells me that this might be a Trone thing going on.
Okay, so you mean that the end-to-end quick could have a separate quick version, and that would be enough indication that it might be Trone.
Exactly, that's what I was thinking, because
that would be another way to indicate this, and I think we would be happy to discuss. I think what the point we want to solve is that there is a problem. Like one nice feature of this is that we can potentially make network elements not having to resort to trial decryption and parsing quick initials. And your proposal there of a different quick version would work as well as this. So I think we could definitely discuss that. Yeah.
If we can get to the similar kind of like one thing serves multiple purposes, that would be good then, rather than trying to build different pieces. Thank you.
Matt Shore. So I wanted to point out something that might be slightly lost in this discussion, which is that part of the utility of this hint is that it would, like Marcus is saying, allow a network element that today is hooking into new UDP flows in the network, seeing if they're quick, extracting the SNI, blah, 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 and then applying a policy based on that. they wouldn't have to do that. So one thing we've heard about at the IETF is that, for example, the deployment of ECH is made more challenging by these sorts of things existing. They are everywhere. They are very common. We can wish that they weren't there, but they are. And so this would allow us to, in that kind of network, achieve similar things, which is to say policy communication without actually having that network element have to parse out something. So it doesn't need to expect the SNI to even be there, even the public one. It doesn't care, because it could just look for the hint. And in the case where, yeah, Trone doesn't get actually used, then it will fall back to its, damaging the flow. But hopefully, we will get to a point where this is more widespread and that's a less common occurrence. So that's one of the values here, is being able to do that really efficiently and quickly as part of the flow setup.
Yeah, exactly.
Hello. Looking at this picture, it reminded me of a mechanism that is currently being discussed about UDP called UDP options. It's currently being in IESG telechat. It's a draft about taking advantage of the different lengths in the UDP header and the IP header to include something after the UDP datagram that serves as a UDP option. And I think it could be used to transport this to an indication, and it solves one of the problems that you have mentioned in the chat, that in quick short packets, you don't have an equation about the length of the quick packets. So maybe you could look at this option. It can help.
That might be a vehicle. I'm a bit skeptical, because the UDP options are typically designed for end-to-end communication, and they operate on different layers than typically the quick stack would do as well. And if you're a quick sender and you anyway padding your initial, but anyway, I think this is a discussion we can have later. We don't have to solve this today. It will be an option on the table to discuss.
Yeah, I agree about the end-to-end part, but maybe this is something that is negotiable. I don't know.
Yeah. Let's enjoy that discussion later.
So we have locked the queue on this particular slide. I do want to get to the end here, because I think please limit questions to things that will help you to understand whether or not we want to take this proposal as the basis for a working group document.
Two points.
Yep.
If you're doing post-quantum, you're not padding your initial packet, so that argument is a little bit shaky.
You can always do it deliberately, Martin. We can choose not to. We don't have to use all the space. We can always put that space there.
Sure, but now you're increasing the amount of data you're sending. And it's a second point. I don't think it's valid to pad an initial packet in quick V1 with something else that is not quick V1.
That's not true. Firefox does it.
We are allowed, because each packet is going to be processed independently. So you cannot go after something other than V1, but if you append something at the end, it's permitted.
Okay, I need to go back to the spec.
Okay, very useful comments. I think, I think the point here is that we want to find, if we can find a way to solve this problem, it's a great thing, right? And of course, we have to be aware of all the details and potential issues with doing it and find the right solution. Okay, I'll move forward now. The other topic is going back to something that we discussed a little bit earlier, like what is the time window for which these throughput devices are applicable, right? And we had different proposals around this. In train, as it's specified, it was not specified at all. SCONE used an explicitly communicated window. The Trone as published, we just put it TBD. Let's solve that later. What we proposed right now for the version that we would like to adopt is to decide on some fixed value. This fixed value is something we would need to discuss, and it would serve as guidance, basically specifying that if you're receiving throughput advice of this protocol, you should expect roughly these time frames of how these bit rates are measured and measured for conformance, etc. This provides some level of guidance on like how much data can I burst in time windows and things like that. The rationale is we want to allow for relatively large burst of traffic, and we also want to maintain the long-term caps. So one problem with throttling that we have discussed in like leading up to the formation of this working group is that while you have the possibility to lower the overall volume that goes into your network, by throttling you typically degrade your radio network performance because you're not allowing for sufficiently large bursts. So we want to find some sweet spot here about ensuring that we can kind of have a long-term rate cap, but do allow for larger bursts. And we think that through proper guidance in the protocol itself, we can achieve these properties. And again, it's a trade-off between protocol complexity and getting something out there. Yeah.
So, but we're not proposing 20 seconds because
20 seconds is an example here, right? So, yeah. So this is something for us as a working group to discuss and come to agreement. And hopefully, we will do some experimentation and come up to some reasonable value. But I think 20 seconds it's not a bad value, but I think let's discuss it and get all viewpoints on this, right?
Yeah. So just a few data points. So from a segment size point of view, it may look like 2 seconds, 5 seconds, so 20 seconds might be enough. What ends up happening is a lot of segment downloads are chunked together.
Yeah.
And then you may have a long idle period, which may be larger than 20 seconds. So if someone's measuring that over that idle period of 20 seconds, they may just get a zero value. So we need to discuss this, and maybe this is a good candidate.
Absolutely. There are nuances here. And we should also see this as like guidance you should be striving for, and there are trade-offs. We want to allow large bursts. We want to give some guidance on like how we maintain long-term rate enforcement, etc. And I'm not sure we're solving that by allowing the network element to explicitly send like 18 seconds or 12 seconds, right? It's the same problem as you described. So,
Martin Duke again. So my initial reaction to this, without having thought about it that long, is that to the extent that we're bifurcating into a buffer bloated world and a not buffer bloated world, that these sorts of like time average burstiness sort of things may not work very well. That a certain amount of when you have shallow queues, it is very difficult to have your data.
Martin, I remind you that this is not congestion control.
Yeah. This is about measuring conformance.
Congestion controller would be the level at which you're talking about managing queues and those sorts of things.
Right, but what I'm trying to articulate quite poorly is that if we're going to have like a single fixed value, that may not be very compatible with like a thing with shallow queues cannot have very bursty things by nature, and so I'm worried that having a fixed value might conflict with that evolution.
I think not. I think we need to have guidance here and describe very clearly how this is not congestion control. This is not going to conflict more than just you trying to select like an initial window for your how you send your traffic, or like you will have this is just telling like I will look at the bit rates and I will enforce the bit rate over this time period. If how bursty you decide to send will be a function of your transmission mechanism, your congestion controller, etc. So if you send very large bursts and that results in a bunch of barrage of ECN marks from the network, your congestion control will react to that, right? So I think we can discuss this further. Yeah.
Yeah, Kulevin. Yeah, I mean, I think it would be very useful to understand what the interval is, but we also have this use case where you might still want to do throttling and you just announce a rate in addition, and then it depends on how your throttling is implemented, what the actual real value is. So if we just pick one in the draft and then the real value is different, it's not useful. So I'm not sure this is very useful.
So, I mean, in the end, as an endpoint, you get this information that you get some information from this protocol. Another piece of information you get is if the throttler kicks in, if you detect packets being delayed or packets being lost, that is information as well that you can make use of, right? So
I think my point is, if we think this is useful information, we should provide it explicitly. Just defining a default value in the draft and hoping it's the right one might not be that useful.
Just one quick answer to that. I think, yeah, I mean, I get that point. But again, we're always coming back to the trade-offs between protocol complexity, how much space we need, and these are trade-offs that we need to kind of.
I think this is one of the questions we need to do some experimentation on and understand a little bit better.
Sure.
Tianji, China Mobile here. I'm trying to think some real case here. Because you have your sender or media sender to send something, well, the SCONE node is going to do some work based on the measurement, and they try to detect use some window size here. But the thing is, for the mobile part, well, there are some real standardized service. Probably you know it already, SRM side, and then they have already predetermined defined some set, and that will have some like the maximal delay budget that being used in the wireless network that allowed. So if that one is going to conflict with what you are defining here based on your measurement, so that means your SCONE node is going to advise the sender say, oh yeah, by the way, you are kind of too fast. And in that case, if the sender does lower down, that means it's not going to fully utilize the wireless network.
So one point, I think this is, we're talking about different layers here, because if you're talking about like a maximum delay budget or something, that is more around the latency that you want to express for a certain class of traffic or something.
No, that is we call the PDU set, the maximum delay budget within the wireless 5G network. So it's within that part. And then that's going to, not the end-to-end.
Yeah, I understand that, but this, what we're expressing here is not something that relates to your delay budget or anything like that. This is just saying that I'm telling you this is a maximum bit rate. This is a rate limit for the flow you have, and I might have some time period for which I am measuring compliance of that bit rate. So we're not saying anything about like what delays you can expect or anything like that. You use other mechanisms to enforce that, right? ECN, whatever, what you have.
Yeah, fully understand your thing, but what I'm talking about the window. You are trying to, on your node, SCONE node, try to measure based on the window, suppose 20 seconds or 10 seconds. And you measure it, you find, oh yeah, now the rate is something, it's kind of too fast. And then you advise to the media senders that, you know what, you're kind of too fast based on the value you're defining here, 10 seconds, 5 seconds, 20 seconds. And the sender, when the sender does respond to your advice, it's going to lower down. But the thing is, it does not know your thing may conflict with later the 5G network it's going to use for that the PDU set, the delay budget. So that is going to cause trouble here.
So if you are a network that have different policies in place, you have to be careful with which policy you want to enforce, right? This is one particular use case. If you have a class of traffic for which you want to provide something else, you need to be careful with what you communicate with endpoints in that case.
Let me think about more.
I think this is a discussion we can have offline, maybe.
Sure, thank you. Yeah.
Trying to make progress here.
Yeah, storage soon. Last one.
Christian? Yeah.
Christian, you're still in queue.
Something in the queue because we were having the parallel discussion on the chat. I think that we really need to, I am totally volunteering to do that, but we need to have the text about the relation with congestion control. Because a lot of the discussion there about detecting throttling, etc., is exactly what congestion control does.
Yeah.
And if you have an element that is going to do the throttle, the best practice should really be to use L4S to tell that to the application. And if, assuming that the application does something like L4S and the throttler marks the excess packet with ECN, then throttling is not a real issue in practice. And the big value of Tron is not to ask the application to send slower, because as I said, I mean, L4S does that very easily. The application, the value is to give the application some confidence that it might be able to send faster.
Yeah, I think that's a useful perspective, and yeah, this definitely can coexist with L4S and ECN marking. Should we move forward? Or Brian, are you?
Yeah, please do. Although I kind of wonder. Actually, go to the last slide. Does anyone have a question about the defense against risk of damage of non-participant flows that would inform their decision as to whether this work is ready as the basis of a working group protocol document? Spoiler alert, there's a question coming.
Gory?
Okay, 7 seconds of uncomfortable silence. Yeah, I think that
I'm not so sure
it's
about this slide,
Oh?
Brian.
Go ahead.
This particular slide's about network elements advice from this group, which sounds like it's kind of a little bit more than what we were doing originally. So I think this slide's a little bit more kind of let's think about this and figure out what we're doing here.
Yeah.
So I'm just stepping in as AD on that one because this is quite strong advice to a different area of the IETF, and we can do that for sure. But we have to think about it. The rest seems to me to be something that we should be talking a lot more about in this group.
Yeah, I mean, so this last slide is about what happens if a network element, with Tron, we tell the network element, look for this signature, and if you see this, you can modify the packet. But what happens if you see packets that fit this signature and you start modifying them, and that turns out to actually damage a flow that just happens to have the same signature as Tron, right? And what we are proposing here is to not do specific protocol work for this, but rather put in some guidance on what you do. Like, if this happens once, then that's probably not a big issue. If you see like a very large frequency of packets having this signature, because probably like if you either have like one random packet looking like this, or you have a protocol that looks exactly like this, and then every packet will look like this. And if you see a high frequency of packet like that, then probably just stop marking them. But this is guidance that we need to work on. We don't need to solve this now. We just want to bring this up, and our current proposal is just to put some guidance in there. Yeah.
Right, and I think that the question, so Gory raises an interesting question as to like the strength of that guidance and where it's aimed, but I think that's definitely something that we can discuss within the working group.
Yeah.
All right, so thank you very, very, very much, Marcus, for driving us through this longer than 1 hour conversation, but I did want to get to the point where I could ask the following 2 questions, although I'm going to skip the first one. Usually here it's like hey, do we understand this well enough to be able to have an opinion about it? And then, what's our opinion of it? I think this conversation has been, at least to me, sufficient evidence of the first question, right? Like, so we've gone really very much into details. A lot of these details, some of these were clarifying. A lot of these detailed questions were, I think, questions that would be excellent questions to re-ask in the working group. It seems to me like there's kind of enough, people have read SCONE, people have read Train. This is, even though this is not a thing that we can adopt yet, because as I understand, there's no document, because this is the outcome of a side meeting after the deadline, right? So we can't actually make an adoption call for this, but that will have to happen on the list afterward. But what I would like to get is a sense in the room for the support for this proposal as the basis of a working group document. So I will start a show of hands there. Do you support the proposal under discussion, so this proposal, as the basis for a working group protocol specification? The outcome of this would then be sort of like feed into a call for adoption on the list. So we'll let this go because I got a couple more still coming in. The numbers are still going up. So, oh, still coming in. All right. For the record, we'll call this at 90 in the room, 41 yes, 3 no, 7 no opinion, which seems fairly broad, rough consensus. Are there people who voted no here who would like to come up to the microphone and talk about why or say what would be necessary to get to a yes? Otherwise, we can have that discussion on the mailing list with the call for adoption. Luis.
Yeah, I think something important here would be the security considerations. So there was some discussion in the chat about the fact that the advice is not, I mean, there is no security on top of the advice. So probably could be used as kind of denial of service for the operator network. So probably we need to insist on the security aspects here to understand so far the information that would be revealed could be used against the network.
I agree. Is that do you think the security considerations are so severe that it's not something we can adopt, or is it?
I would prefer to have clear that dimension, so to understand what could be the implications at the time of defining the protocol, because maybe we need to do something specific for that.
Sure, I agree, but I guess that goes for any protocol we publish, right? That we need to have careful consideration of the security.
Yeah, we will not send a protocol document to the ISG without a security consideration section that specifically looks at the security considerations for all participants in the protocol.
Yeah.
Okay.
All right, so thank you very much. We will follow up with, I guess I should terminate the show of hands. We will follow up on the mailing list with a call for adoption, as I think technically we have to see a draft before
we'll get to
we can do a call for adoption. So please send a draft and then we can do a call for adoption on that draft. All right, thank you very much.
Thank you.
Thank you.
Let's move on to the next topic. Sanjay.
You're going to change slides?
Yeah, I'll change now.
Hi, my name is Sanjay Mishra, and I want to present something completely different than the last hour that we spent. So this is kind of an antidote to what we just heard. So this is really focused on what should be the use cases and requirement, and actually naming the name. We've been talking about network element, so let's name the name, right, for what that network element is, at least in the proposal. And I realized that SCONE is just a working group. It's no longer a signal, so change that to Tron. Next slide, please. Oh, thank you. All right.
Yeah.
Oh. All right, thank you. So this is really at a high level, pretty much the overall summary of the draft. There are like 3 or 4 things that I wanted to just make sure that I bring to your attention. I don't know if you've read the draft. So this is the draft that Anoop and I have submitted from Meta, Verizon. So number 1, the purpose really is to try and focus on what the charter says, and the charter says that there shall be a network element that is currently capable of rate limiting to help with the throughput guidance. So the draft is meant to sort of provide an input into what that network element can be based on where we are today. And then the second part of the draft is that it lays out the view of what the network element looks like in a 4G network and what it looks like in a 5G network. And then obviously we talk about some requirements from the network side as to how the Tron signaling can be implemented. And then lastly, trying to say that we're not trying to say here what the what inputs network element should consider in order to decide throughput guidance. But we have taken the view of that the lowest hanging fruit in terms of the network element typically is knowing the subscriber plan that it knows, and it knows the radio access technology that you're on. So it can take a combination of those two values to determine the throughput, and it's not taking sort of congestion control into, because that's a different realm where that happens. This is really trying to solve the problem between the network element that is trying to hand over packets to the radio network, and the radio network will only accept the time window that it has, how many packets it can take. So we're just trying to solve the problem as to how fast or how slow that transition needs to happen between the packet transfer needs to happen. Okay, so this is just sort of a 3GPP view of what the 4G and the 5G network looks like. And the point we want to drive here is that today, much of the functionality that is in terms of the policy that is enforced is either on the packet gateway on the 4G network, or it is on the user plane function in 5G networks. And as you see, I've listed out a number of features that the packet gateway in 4G or UPF in 5G is capable of, including providing the connection towards the radio network and also providing connection towards the public data network. It's capable of understanding the incoming flows, and it enforces policies and policy charging rules, etc., QoS handling, and allocation of IP addresses, etc. So it is really the point here is that UPF and packet gateway do this today. So they would be the best candidate to be considered for doing drone signaling. This is a little bit more drill down view of how a drone signal can be carried over the 5G network. And there's a similar view, I think, maybe in the next slide on 4G. So really what we're saying here is that you have a path. UPF provides the on path for connecting between the radio network, the G node B, and then from G node B over the radio link to the UE and the client app on the UE. So UPF can carry that signal, that drone packet, I should say, between the UPF based on the subscription policy, based on the knowledge of radio access technology at the point in time. And if the drone packet comes, it can use that information and provide guidance back to the endpoints that this is the supported bitrate for this particular flow. And then the clients can, the endpoints can go merry about with their flows. Please, if there's any questions, I don't see what, Yan? And this is a similar flow on the 4G network. Essentially, as you see here, the packet gateway through the SG gateway, and then onto E node B, and then the end client. This slide is just talking about some of the requirements that that we thought would be at least need to be considered. And I'm going to just read them out real quick here. The first one is that a drone signal must be a client application endpoint initiated. And it is important because the UPF or packet gateway just need to really see the uplink flow, and based on if it's client initiated, then it only needs to know when it sees a packet coming in from the client side, and then provide the guidance. Then the next requirement is basically once it understands that on the uplink flow that this is a video flow, then based on the available service plan and whatever the radio access technology is, it can add the throughput advice, and then it can send this throughput advice back on that flow. And then this is the third requirement is sort of a should here, because the reasoning, what we're thinking is that the client app should acknowledge the receipt of throughput advisory. This is only from the point of view that if the network knows that the client has received it, then it does not need to reattempt to send, thinking that the client has not received the guidance. But it's not a critical to the flow, because as long as client can generate a Tron packet again down the stretch, as Marcus was saying, then this might work. The fourth requirement top down is that the Tron signaling must not require changes to how the CSP determines its video policies today. So, and this goes back to the first part, that we're not mandating as to what a given mobile network decides on how it wants to enforce. So it's just saying that whatever process they have, this is not changing that, but the only consideration is that however you calculate the throughput advice, you just use that. The fifth bullet down is that when the radio access technology changes, then a UPF or packet gateway should be in a position to send the new throughput advice to the endpoint application. The sixth bullet here is that application should self-adapt the video flow based on the throughput advice it receives, and this is really a should. It's up to the client as to how it wants to request, but best is to stick with the guidance. If it received it, then use that guidance for a harmonized flow. And then the last requirement is that Tron signal must be extensible to networks beyond 4G and 5G. And this is, go ahead, Martin.
Hi, Martin Duke again. Can you go back a slide? I know that it's a moving target based on the last discussion. Is it your opinion that the Tron proposal, as you understand it, meets all these requirements?
Good question. So I did raise some questions on the GitHub to get some clarification on based on the requirements that we have. So I've put out 3 questions there, and I know we're a little bit out of time, but no, it does not meet all the requirements that we have here. But some of those, the main point is that the gist of what Tron proposal has in concept, it is meeting some of these requirements. There's maybe some tweaks that may be needed, okay. But we're not that far off.
Yeah, it seems like the third one is not, but okay, thanks.
Can I quickly comment on the third one directly? Sorry for jumping the queue. I think that one is actually not needed at all. You said it's a little bit optional, but the important part is the first one, which is like the client indicated it understands the signal, but then like that you actually have received the signal doesn't mean that you act on the signal. And so I don't think that's useful information to the network to really understand if it was received or not.
Yeah, I know we're a little bit out of time, but I can continue to talk on the GitHub to get more clarity. This is a access agnostic view that this is easily extensible to architectures beyond 4G and 5G. And I know we didn't spend as much time given the time constraints here, so I'm going to leave these questions for the working group chairs to decide as to how they want to take up this document.
Yeah, we run out of time. Please take your comments to the list and also share in the window. So we.
Thank you.
Yes, thank you. And go to the next. I think it's SCONE taxonomy. Yeah, Kieran Cross, and I will share slides for you.
Sound good, thanks.
Go ahead.
So trying to figure out how I can move the slides, or are you gonna change them for me?
Yeah, sure.
Okay, sounds good. So yeah, this is another proposal, rather a discussion on some empirical. Kyriakos Zarifis from Meta here. Rather a discussion on some empirical observations on the state of throttling and some of the policies we see used worldwide. Next slide, please. So first, a quick recap on why content communication service providers may employ throttling for a variety of reasons, including the need to be able to differentiate across different tiers, different plans, including data cap plans, the need to ensure fair usage policy, and make sure that the infrastructure has the ability to satisfy the users that are using the network, especially in times of high congestions or busy locations where throttling might be a way to mitigate the congestion that is happening ephemerally. Next slide, please. I'm just going to go through these fast because the audience here is very familiar with these things, but at a high level, the main two implementations of throttlers are publishers and sapers. Publishers drop packets that do not conform to a committed information rate. Sapers, on the other hand, buffer those packets in the network to schedule their sending later, thus achieving a more stable rate near the committed information rate, but also inflating the RTT versus publishers that drop packets and introduce high retransmission rates. So while the motivation for throttling is there and it's very valid, it can have, the way it's implemented can have some side effects and impact on all players. On the communication service provider side, they can take up CPU and memory resources depending on the implementation. Dropping packets will introduce network overhead and retransmissions. On the content application provider side, and for the end user's quality of experience is impacted. Again, retransmissions can take up CPU overhead on the server side. The end user's devices might be affected by, we talked about this a little bit, having to sleep and wake up more inefficiently in the presence of shaping and not utilize bursts. So there's impact. There can be negative impact in various places. Next slide, please. So this slide kind of summarizes some key takeaway points from a few different studies in trying to understand what throttling looks like in the wild. A study from Google in 2015 saw that 2 to 7% of video segments were being policed. Out of those, 30% of the policed video connections were throttled to something between half a megabit per second and 2 megabits per second. That increased in retransmission at very high rates. 2019, Northeastern University did a study that involved several content providers, found a bunch of ASNs that throttled usually around 1.5 megabits per second. Interestingly, they could treat different services differently. And they also, had always-on throttling regardless of network conditions. And a more recent kind of analysis that we did at Meta found 200 ASNs outside the US and 275 globally that implemented throttling. This table in the bottom kind of breaks down the percentage of those ASNs and what bucket of rates they were throttling at. So next slide. The next slide essentially visualizes kind of the regional trends, and this is not to be taken for ground truth or anything. This is a very high level, noisy signal, but kind of showing which regions were affected at what rates. So we see South Africa, South America, lower rates, Scandinavia, higher rates, and so on. And North America somewhere in the middle there. We can move to the next slide. This kind of also shows the ranges. It's kind of interesting related to the previous discussions of granularity. But anyway, I'll move on to some taxonomy-related observations in the ways that throttling policies are being implemented. So we see a bunch of categories. You can have throttling that is based on the application and it's like always-on umbrella throttling. This can be used to throttle specific types of traffic, regardless of network conditions. Others implement time of day based throttling. So during peak hours in a region, they throttle at specific rates. It's also used to enforce or facilitate the ability to serve data capped plans. So once data quota is exceeded for a user, you start throttling at a specific rate. This could be a daily or monthly quota. It could be manually topped up by the user. There's user-specific policies to create different tiers of services, and like discussed before, there can be network topology-specific policies. So depending on what kind of network you are, you might want to throttle at a different level. And so these are all observed in the wild. We see a very kind of diverse, breadth of policies, and interesting, importantly, a lot of these can be combined. We can go on the next slide. So there's a trend more and more towards throttling over the last 10 years or so across these studies, sometimes towards lower rates as video traffic explodes. The different policies vary dramatically across regions, and even and across CSPs in the same country. User data caps are prevalent globally, and there is a need and a trend for content providers and CSPs to want to collaborate on achieving kind of a collaborative way to find the way to achieve this fair users policy. Next slide, please.
Can you wrap up?
Yeah. So this is actually, I can skip completely because it could have been an intro slide to Marcus's talk, basically just talking about design considerations. But we had a lot of discussions with it.
You want to add a comment? Yeah, Magnus.
Magnus Westlund Eriksson. On your categories of throttling, I didn't see what I suspect it is a common for Sweden example is subscription-based throttling on peak rates, because I think that's fairly common both on fixed and mobile.
Is that, just to clarify, is that what does that mean? Just to make sure
I would say, for example, I know that my fiber link, which is physically 1 gigabit, is throttled to 500 megadown and 250 up.
Yeah, definitely.
I think mobile subscription is peak rate limited to 100 megabits.
Yes, I think that would have been the fourth bullet there. Maybe it wasn't phrased, but I think that's mapping to what you're saying.
Okay, I think we're in the end of this presentation. Thanks, Karen Cross. So sorry to squeeze your time. Yeah. So we need to wrap up with the working with chair slides, and I will share. So, Brian, you want to take on?
Yeah, I think the only really important thing that I wanted to get to is now that we're going to have a combined protocol that we will put a call for adoption out to, we'd like to make rapid progress on a lot of the questions that we were discussing today between now and Madrid. And our proposal is that we actually set up a fairly aggressive virtual interim schedule. I think I discussed this on the list prior to Bangkok, or sent it to the list with no discussion, with sort of like an every third Wednesday sort of cadence. We can take the discussion on these timings to the list. The idea is we want to sort of like rotate the open meeting times so that we spread the time zone pain, right? Because like in the previous interims, we had problems that some participants were just not able to attend because it's like, it's always 3 in the morning. So we will have a discussion about that out on the list. The idea here is we'd have sort of like 5 meetings scheduled as soon as we can get those scheduled, and then use them if we need them, and then sort of like decide at each meeting if we drop that off. Another goal is we would like to see what we could do for a hackathon at IETF 123 in Madrid. To that end, I actually will be in Madrid and I'm landing on Friday night, so I can provide support to anything there. We can discuss that on the list as well. Oh, cool. With 0 seconds left, we have people in the queue. Miria.
Hi, one quick comment on the drone document or the working group document. Maybe please consider just having 1 or 2 editors because we have a broad set of opinions in the working group.
Yep. Thank you very much. Dan.
Yeah, Dan Drutze. I'm wondering, in terms of the deliverables, do you expect the specification Tron, which will be the adopted one, be the only document? Because I think it misses some of the requirements. Sanjay mentioned about requirements. It misses some of the semantics that we were talking, that there are some drafts like the session data array that I mentioned, that I submitted, clarify so what actually that advice means, both from a network and the content provider. So I just feel like the protocol is the beef, but I think to make it coherent, we either have separate documents or we have one that gets complemented with some other pieces that have been submitted. That's all I was.
So yeah, I think we have 2 deliverables, and we will be doing sort of an adoption for the second one. One of the reasons that we have want to have a bunch of interim time is so that we can also make progress on that other one, right? Like, so I think that the strategy we've been using is we need a basis, like a concrete basis for experimentation, and then once we have that, the applicability, manageability, requirement statements can also be done. So I wouldn't, do not take this as a, hey, we have our document, we're not doing the other one. The charter says we have to. Also, do not take this as we're only going to be working on the protocol document in the interims. So yeah, we'll like part of the reason of having so much time is so that we can discuss both. Is that a good answer? Does that address your concern, Dan?
More or less, because the applicability, I agree, it's a totally different story. But even for the protocol, we're not setting the stage in terms of what exactly some things mean. We're diving directly into, hey, this is the value, this is the bit rate, and so on. But we're not providing enough context. That's all I'm saying.
Okay, those are definitely things that we want to discuss on the working group document, right? Like, so we get to the point where we have a working group document, so we can do that.
Okay.
All right. So with -2 minutes.
Yeah. So thank you everyone to participate in the meeting. See you in Madrid. Yeah. Thank you.
Thanks all. See you in Madrid and in the interims in the meantime.
Make progress. And then I agree. We need to work a lot on semantics.